Redraw is out. The jig is up. The secret is out. Redraw is out for people to see. Uh, it's very exciting to finally get to speak up about it. We've been kind of hiding it, and also
Yeah.
like inside the company, we had an internal name for it called Project X. And anytime we were kind of referring to redraw at our desks, since we have an open office, we were just saying, hey, we have this, like, we need to prepare this demo for Project X, like, can we take a look at that? And it was very funny to kind of keep that secrecy and be undercover. And yeah, it's equally fun to share this with people. Finally, we saw a very good reception on the YouTube video. How are you feeling, William, after the announcement?
Yeah, so definitely the reception has exceeded my expectations. So really happy. I received a lots of great comments from industry experts on in the field. That was really heartwarming. And yeah, I have to thank you. So this is part two of the first video we shot, and actually the last video where we were looking at the Wixel WASM transpiler was basically me doing this fun demo, but after what happens that
Mm,
I showed you Project Redraw for the first time, I had already alluded I was working on something with TypeGPU, and you were
yeah.
supporting me with my requests. And I have to say, psychologically, it was really hard to work on something alone. So I really appreciated that I could like share it with you, and you spent so much energy on this project. So that
Oh, of
was really
course.
also energizing me back. And yeah, so this was really cool. And yeah, now that we announced it, I'm almost like the real work begin. Like that's but it's pretty, yeah, pretty exciting. And did you guys receive also any interesting feedback on like type GPU and how it's used in this context? Or
When I was looking at the comments, I mean, I saw a lot of interest from people just like being interested. Hey, this is like this use GPU thing. How does it work? Is it similar to TSL, the FreeJS shading language feature that they're working on there? And it was awesome to see that interest. And I mean, the parallels definitely there. I feel like we're trying to solve a very similar use case. Um, but I feel like, yeah, like TSL um, gives that gives that ability to FreeJS, while TypeGPU tries to give that ability to other frameworks and libraries. And yeah, it's awesome to see like Redraw pioneering that and taking that leap. Because we feel like, yeah, like TypeGPU, we're really trying to put in effort for it to be a great developer experience, for it to be able to abstract frameworks and users using those frameworks um, in a way that's composable. So it was nice to see that it was like people were just feeling it uh, as a natural progression, and the way you kind of presented it in your presentation as a kind of a step forward for software management in terms of reanimated worklets. I feel like that also clicked for people, and so definitely something that I'm going to touch on my in my App.js talk. Uh,
I
um,
agree, like
yeah,
from a cultural perspective, the approach you took makes a lot of sense. And when I got started with Redraw, I didn't know if I would use Type GPU or anything, because it's like step one. First, you feed in some Wixel code
yeah,
directly. And first I thought, okay, this is the only way people are gonna do it. I want to provide some nice utilities for people to so they don't have to do so much boilerplate and so on. But I think now I'm gonna remove all these utilities and make the code base lean. If you want to write Wixel code, you're on your own. We recommend you use Type GPU basically.
mm,
And then okay, so this was step one, and then step two is to think, but we can, and it's a bit like the TSL approach to say, we can add like some declarative constructs.
mm,
And then also, I looked at the CSS. So right, you want to describe a curve for color, stroke width, everything is a curve basically. the feathering, and I looked at the CSS spec, which is like a declarative way to
Mm.
specify, you have like easing functions, and now you can like give like polylines as easing functions and so on. And I was like, oh yeah, that's pretty good. That's uh, one thing we could use. But then with Type GPU, I think the value proposition was just so compelling, and again, like so also uh, culturally close to what is done with like reanimated and worklet. And as I mentioned in the announcement, I loved that. First of all, it's like done at bundling time, which I think is pretty cool. And of course, for me the final boss of writing shaders, the killer really use case is if you have like the operator overloading.
Mm.
Then this one, I mean, everyone wants to write shaders in TypeScript, but if you don't have operator overloading, you're really missing out. So
Yeah.
um,
Yeah,
yeah,
we were really, I mean, I'm kind of like, for some people, like compiling TypeScript into WebGP chain language may seem insane, and I understand that. But we kind of took a look at it as like, if you wanted more features in Wiggle, you would have to kind of, and for it to be up to par when it comes to TypeScript, you would have to add so many functionalities, like splitting up code into multiple functions, having generics, having even polymorphic functions, um, and having like comp time specialization and stuff like that. To add that on top of Wiggle, you would have to do, I feel like, a lot more work than just adding operator overloading to TypeScript, which kind of makes it a competitive shader language. So to us, it felt kind of natural to be like, hey, like we're familiar with TypeScript. TypeScript has all of these functionalities built in already. You have all this ecosystem and tooling already in your project for bundling the TypeScript, for doing tree shaking and everything. So why not kind of use that, leverage that, and make TypeScript, just fill in the little gaps that make TypeScript an actual shading language. Um, and it's awesome. I mean, we've been, for so long, we've been kind of down on the low level trying to make TypeGPU a shading language. And it's awesome to see Redraw pick it up. We've been trying to like do some experiments on our own. Both me and Conrad have been doing like game engines on top of TypeGPU, and that was very fun. Um,
Still working on
Still working on it, yes. We might have more to share in the future, but yeah, like, what do you think, Conrad, like when you first saw Redraw, how was it to see your work like incorporated into another project and an API around it?
Yeah, I feel like Redraw is something I imagined when we started working on it,
Hmm.
because we had the same idea. I feel like just writing shaders in TypeScript and having a library use it to just give you some callbacks that you can customize logic in an efficient way is like exactly what we had in mind. So it was like a, dream come true that someone that's not us actually made it, used it, and it works as well as it works now. So yeah, I think that's really good.
I mean, how it started was really, so I was obsessed with these Apple pre-intro graphic motions,
Yeah, yeah.
and these are done with insane enterprise software like Cinema 4D, for instance.
Mm.
And I think for me the first step was, so in their presentations they use insane feathering effect, colors along path,
Mm.
variable strokes, and so on. And for me, the first step was to learn how to do it using shaders, using by programming the GPU. And I think I started at some point to get the hang of it. And once I kind of understood how these things were made, I was like, okay, how do we package it in a way that is as easy to use as Canva 2D, basically, or Skia?
Yeah.
And this is, I think, the case you made in the announcement was really strong, and also to bring it back first to the idea of callbacks, which are so important. And here in Redraw, the rules of the game are very, very simple. You have a stroke width, you have a color, you have a feather, and these are JavaScript callbacks, each one of them. And they received 3 parameters each, plus animation values that you add, plus arbitrary parameters you want to add, arc length of the path, distance to the path, tangent to the path. And so very simple rules, very simple sandbox to play with, but somehow infinite possibilities, because then you can create any arbitrary rendering that as the one we've seen. So here we have an example of a redraw path, and again, just a color node and a stroke width. We add some animation values, and to a TypeScript developer, this might look like really regular stuff, right? We have colors, we do interpolate. But if you come from the shader world, there's a couple of things here which might seem a bit unusual. So
Yep.
first, I mean, we have Unicode characters in the shader, which is somewhat unusual. And I would say also we interpolate things with um, arbitrary array length.
Yep.
Again, not something you see a lot into shaders. And I think you in the presentation also you made a really compelling explanation of what's happening here.
Mhm.
So, for instance, what is this color function, and why can I pass a string to it?
Yeah. So, I mean, to kind of to step back a little bit, we because like we have a couple of steps in the process before we end up just using WebGPU as you would if you were writing regular Wigzel. So in the end, this whole string has to somehow generate valid Wigzel. That's actually something that you could write yourself. Um, but because we have this processing step and we're taking a look at your JavaScript and we're able to say kind of what do we want to do for this particular code that the user wrote. We gave users a little bit more tools that they can use to write their shaders in a more familiar way, or just in a way that some of the computation can be done before the shader actually gets generated. So in this case, the color function is something that the user marked, or in this case you, William, because it's part of the standard redraw library. The color function is marked as comp time, and what that means is that all of the arguments passed into it have to be known at comp time. Like if you look at it, it cannot come from like another part of the shader. It has to be something that we, by looking at the shader, we're able to say, okay, I know what this is. I don't have to actually run the program on the GPU to know the value. So in this case, the color hex string like doesn't actually exist in the shader. We're able to capture it during the shader generation process and call the color function at comp time, as we call it. So during the shader generation process, and we just take the result of that function and then we do more stuff with it. In this case, it's just put into an array. And if you look at the resulting shader code, it's just an array of vec4s, right? I think the color function returns vec4s.
Yes.
Um, and I mean, we have a lot of these kind of functions that make it feel like TypeScript and JavaScript. But it's very hard from a communication standpoint to explain to people these kinds of functionalities without them feeling like we're adding on to the runtime. That's like we're adding a runtime cost. Because we can say like, hey, we have like callbacks on the GPU and we have like strings on the GPU. But if we are not careful, then they might think that we're like shipping an interpretation machine to the GPU. And we're adding like string support to WebGPU shading language. Like we were sending bytes of Unicode or something. But we really want to we really want to make sure to that people know that hey, like these functions are comp time. They don't contribute to your code like running slower on the GPU. Actually, in most cases, the code that you write in TypeScript is ends up being faster than what you would probably write yourself in Wigzel. Because
This
it's
part
just
was
your
interesting, right? Because
yeah.
when preparing for the announcement, you and I, we looked at some example where we realized that's actually hard to beat some of the generated code that from TypeGPU to Wigzel by writing it manually.
Yeah.
Which is often the case, I guess, in when you get better and better at code generation.
Yeah, that's true.
Yeah, I think that's how compilers basically work. Yeah, it's hard nowadays. It's hard to beat a C compiler as writing C. Yeah, of course, we are not at the level of a C compiler, but we have some assumptions we can make that make the generated code a little bit better. You could make it as good as we do under the hood, but it's just less effort for you. So at the end
Yes.
of the day, it's more convenient and more performant often. Of course, you can always shoot yourself in the foot if you write some code that's bad, but there's no saving people from every piece of bad code. We try our best.
Yeah.
That's a extremely powerful concept, and you mentioned just in passing something which I think should be almost its own announcement is that you can use console.log in
Yes.
the in the shader.
Yeah, and it's follows the same rules as the contain functions because of course you don't have console log on the GPU
Yeah.
like you don't have the web runtime on the GPU, but we are able to just inject Wixel code that makes it work as you would expect it to. So I feel like that's on its own is like a great showcase of what's possible to do.
So here in the logo, you use the SVG paths of the TypeGPU logo, which you add already, and during the presentation, I used these beautiful SVG paths where you can like have like all these beautiful effects. And of course, one feedback I received is okay, cool, but now where can I get these beautiful SVG paths?
Mhm.
Now that I can apply these crazy effects on it, how so of course the idea is that SVG is such an ubiquitous primitive. I mean, Figma, even PowerPoint, like you
Yeah.
can have like these vector assets. They are really widely available. But of course, so one thing where um, a lot of the demos I've shown are based really on single stroke line um,
Hmm.
SVG assets. So for instance, here's the Hello path. It's a nice and clean Hello path, which I use since many years now. And of course, it produces the asset. But these single stroke line designs are actually pretty rare. There are some communities which if you engrave, for instance, into metal or things like this, that use single stroke line fonts or I mean, there are some also icon libraries which are like, but usually you have an outline, and which is okay. Of course, you can work with paths with who have an interior, but some of the effects will be harder to. I mean, here you see you have like the self intersections and the medial line can be harder to deal with. But so I'm thinking. So I did receive many feedback on this point, and that's a thing I'm thinking about it a lot. So you see here, it's not like so. This is any SVG path that you can copy paste.
Yeah.
But here I do something different. Is that I use a single line font. So here you can say type GPU. I mean I with this font I don't like the
It's very cursive, right?
yes yeah
Yeah.
exactly. I don't like the uppercases later, but maybe I can make the stroke width a bit smaller because the text is large. But so this is you see you can write anything. It's an SVG font that is single line stroke. Of course, this works, and I used it in the presentation. You can use fonts which also have an interior, but depending on the effect you want to build, of course. Um, and I have another one which is more like a classical, let's say, Rubik font.
Oh, that's really cool.
So
I love that.
ah, maybe you can make it a bit bigger the stroke width, but
That's very cool. Yeah, like there's I see a lot of these like satisfying TikToks where people create like clocks from I forget what they're called, but like weird materials that kind of change over time. This kind of gives me the vibe of that. I would like to see that on my home screen.
so it's a hot topic I'm thinking about a lot. So how can we, even myself, right? How can I like more easily work with paths and have like um, yeah, even I found that in Figma and these paths, they were really hard to edit. And now that we have like all these rich things we can do with paths, I think the way we want to create path and edit them also needs to be richer, because uh, the possibilities now are much bigger.
Right.
And of course, during the presentation, all the graphic motions
Yeah.
were done in Redraw itself. So this was really cool because we show like all these cool effects, and it's done using the technology itself, which I really love. And I was also telling myself, even if no one cares about this new project, I still can use it myself to make like cool videos, because you can really build some of the cool effects. So here we have this is Remotion running with Redraw, and here we have the hello path that was used in the first opening shot. And so we zoom in, we segment, so we can segment the path from 0 to 1. So then we go from 0, 1 to 0, 5, right? So it's gonna uh, and then we fade also. So the fade is based on the geometry of the path.
Yeah.
So that's
Yeah.
why
Amazing.
it
Yeah.
gives this
That's
cool
very cool.
ghost like effect.
Yeah, I mean, I feel like it's a testament that if you want to like if you yourself want to use your library, then I mean that's what drives kind of development to begin with, right? And yeah, I have to say, like, we did a watch party of the the announcement video, and a lot of people were praising the production value. They were saying, "Wow, like, does he do that every time?" uh, and yeah, I have to say, like, it makes a very good impression. Like, all of these shots are so like well edited, but also like the base footage is very good, and I feel like that itself like attracts people with a similar goal in mind, where they want to create production ready and cool looking visual effects. Um, yeah, yeah, it's a very good tool to have in your tool set.
Yeah, and I think one thing that it's important to mention, because William mentioned that we are looking like the Apple production quality, like Cinema 4D, but this is running on real time. It's not pre-rendered, or the Redraw stuff runs in real time, even on weaker devices. And yeah, I feel like that's important to mention, because you look at these beautiful effects and you might think, yeah, okay, but I have to render it for 10 minutes or something. And in realistic resolutions, I feel like it's just runs and looks just as good as a pre-rendered effect.
I had the exact same thought, where I was like, "Oh, we forgot that this is actually running in real time."
Yeah.
It's pretty cool. And yeah, and so all these physics-based rendering, we have to kind of add some sort of is topology the right word, right? So here we say, when I show the path looking like this, or in ceramic, it's like we treat it basically as if it was a cylinder. Or if
Yeah.
we do a bevel or embossing, it's like we say, oh, this is a cross section of something else. And um, yeah, it's something also I need to like I said, we just announced it. There's so many things we need to think about. And obviously now the real work begin, I would say, to think about these primitives and potentially the level of composability. So we showed really what I wanted to do was to do, okay, variable stroke with a color along path, uh, variable feathering. And then, there's like all these other benefits that we got for free that I could show during the announcement. I think analytical motion blur was a really cool demo, where now you can, you can add motion and have like the blur being part of the design, and the motion of the vector effect, which I think you can build some really cool. I was thinking about a tape uh, that's rotating, a tape recorder, and then if it rotates very fast, you
Yeah.
can blur it, but not blurring it through raster blurs, but through motion.
That's so cool. Yeah.
the physics-based. So the fact that you can do things like neuromorphism or physics-based rendering, but in a procedural way. So I see so many, even recently, tutorials of people. They show you these beautiful designs on commercial software, and then they say, "Oh, I saw one yesterday. So, oh, you need to put this shadow and you need to put this shadow here and
Yeah.
blend it together, and it takes 2 hours." And of course, where I think these things now they can be done in a procedural way, but also one thing that where I felt like the time is ripe for like new primitives is so web GPU. So the fact that we have a unified runtime uh, between libraries. So this is really encouraging because if you don't have web GPU, it's like, you want to do Project Reader, okay, so you're gonna rebuild the whole world like a whole new graphic library. But actually, no, it's like I can
Yeah.
just build my own little contribution and use it with existing libraries such as like Skia and 3GS. And one of the demo we showed during the announcement, I think, um, is the fact that you can mix. So this
Yeah.
is HTML, Skia rendering. In fact, I can uh, change the text. You see, you have emoji. The font is from, so it's HTML font. And so I can say hello, redraw. And
Mm.
you can integrate. And this is a redraw path with like self intersections, color elongations, and so on. But you can integrate it at zero cost with existing 2D primitives.
Yeah.
And yeah,
I was wondering how that worked. Because I remember. I mean, I was using the Redraw API to do the TypeGPU rods demo, but how did you achieve like the self, not even the self intersection, but the intersection between objects on yeah, like a single object with a different object in between that object. Is
yeah,
it separate objects?
that's a great question. And it's interesting because here actually it has nothing to do. You could argue it has nothing to do with redraw. I always wanted to mask
Hmm.
because this could be a Skia path, right?
Yeah.
The only thing which is redraw specific here is that the path has like these higher qualities like color elongation, variable strokes, and so on.
Okay.
But the way it works, and I think deep in your heart, you know how it works, is that, of course, it's just a simple mask
Okay.
between,
Yeah.
right?
Yeah. Yeah.
So
Yeah.
I have the two textures and I mask between the two. And of course, you could do something more sophisticated where, especially in Skia, where you know exactly the bounding box of each word, each glyph even.
Yeah. Yeah.
So here I just act something together, but you can.
It makes
And so
sense. Yeah.
yeah, it's not redraw specific, I would say,
Mhm.
um, but it's pretty cool. I think I don't. I mean, you saw on Twitter, people are getting very very excited about HTML in Canva, as they
Yes.
should. For us with Skia, that's a problem we were looking at since a long time. Now it seems to be solved. So the problem is this. The problem is the silos right between graphic APIs on the web, and that opens the door for people to build I think great graphics
Yeah,
on the
I
web.
agree. Like it was kind of surreal because we were conceptualizing a new demo a la Jelly Slider, but using different techniques. And we were, yeah, I won't spoil what we wanted to do, but we kind of wanted to do something similar to HTML and Canvas using a different technique, um, more akin to like SVG filters, which also were able to apply some displacement and blur to the background. But we wanted to generate that mask dynamically, and we were like, "Oh, this is really cool! Like, I haven't seen anyone do this before." And like a couple days later, they announced HTML and Canvas, and it was like, okay, okay,
Yeah, and they even
now,
used Jelly Slider
yeah,
in one of their
As the
examples.
demo,
Yeah,
yeah,
which
yeah,
makes sense, of course. Yeah,
yeah.
yeah. We were wondering like, can we use this technique to like have the background displacement or of the jelly slider, and then they did it for us. That was kind of surreal, but it makes sense. Like with this new kind of push for um the oh my god, liquid glass, right? I almost
Yeah.
forgot. The liquid glass and the new movements, and I see a lot of people just experimenting with different looks for their apps and for their experiences. Um, and yeah, it's awesome to see that there's a real push for it, and HTML and Canvas might become something really. Hopefully, it's gonna be supported soon-ish. We all know how that works.
It's going. Let's say it's going in the right direction. Then
Yeah, looking at you, Firefox.
Yep.
yeah. But liquid glass is a great example because I think so many people were onto this problem and trying to push it. So the problem of the silos, and you try to find motivational examples and you give motivational examples. But then when Apple came up with liquid glass, where here clearly you need to break the silos if you want to
Yeah.
implement the effect. And it's also I like how people so when it came out they walk around the issue anyways and they find like
Yep.
some really clever tricks, but you know that okay it's cool, it's a cool demo, but that's not really like practical. But I still love like the creativity that people use around these problems. But liquid glass like was really like the established mainstream motivational use case to break the silos on the web. So we are meeting next week at App.js, so that's exciting. I just wanted
Yeah.
to check in, Ivo. Where are you with the talk preparation? Are you stressed? Do you have a lot to do, or things are pretty relaxed? And
I'm pretty stressed. Yeah.
okay,
I mean,
I thought you were about to say I'm pretty relaxed.
I'm always stressed. Like people are always surprised when I say that I'm stressed out because apparently I don't show it that much. But yes, I'm stressed out. I mean, it's like it's gonna be awesome to meet you again at App.js in person. And a lot of the people that are that I've met last year, and I'm excited to meet new people that are just getting into the space. And yeah, I'm really excited for App.js. I'm stressed because like I want to really um give people something valuable that they can use in their own apps. So I'm just putting a lot of effort into making sure that my ideas come across clearly, and it's not just theoretical stuff. It's actually something that people can take and use. So yeah, very excited, very excited. No slides yet, but
A lot of ideas.
a lot of ideas. I'm writing the script. It's like halfway done, I think. Like the actual thoughts on paper or the words on paper that I want to say. And I'm gonna do probably like a test run tomorrow, just for the content in front of the guys. And we'll see. Yeah. How are you with the talk?
sounds good. So the no slides yet makes a lot
Yep.
of sense. I would say I'm somewhat advanced in the presentation, but no slides yet. I think I will start with the slides midweek. I think.
Yeah. Yeah. Same.
Pretty excited because because of the Redraw announcement, I didn't have time to go to give an update on React Native Web GPU, React Native Skia. So I will the talk at App.js will be an opportunity
Yeah.
to give an update there. So I'm pretty excited. I also I could like give some love to these modules, which I was so focused for the announcement on Redraw. And yeah, I'm pretty excited. Some really cool stuff on Skia Web GPU, which I'm pretty excited about. Also, really heartwarming to see some of the examples people in the community are building
Yeah.
using these modules. So
A lot of so much cool stuff on Twitter I've seen recently. Yeah.
yes, it's really crazy. So yeah, really happy, really excited to meet everyone next week. It's my favorite time of the year, so I haven't missed a single edition. So yeah.
That's awesome. Yeah. Yeah. Can't wait for it. I'm very excited. Yeah.